we'll jump in.
All right. Boom.
The white paper series, part 2. We covered in the first one. If you haven't seen it, go back, watch it. We covered the abstract, introduction, transactions, and timestamp server. So now we are left with sections 4 through 6, which are going to cover proof of work, network, and incentive. And this is pretty much like the meat and guts of what Bitcoin is, right? Because I think that what I find the most interesting is you can actually take sections 1 through 3 and pretty much describe the majority of blockchain projects, right?
Yeah. I mean, I was gonna just say like the sections that we reviewed in the last show kind of like really went into like the high level of why Bitcoin is, well, not why, but the goal of Bitcoin and blockchain technology and the efficient system that they're trying to create. And then today's going to be a nice transition into like how that is an efficient system, which a lot of people always forget.
Yep. Yeah.
So
we'll jump in.
Yep. Perfect.
So just kind of read this section out loud. Hopefully people listening. We got a lot of good feedback on the last one, so I hope that this is still valuable to people. And I think really what we're about to start getting into is kind of more of the guts of what's going on here. So we'll see how we do. But all right, so section 4, proof of work. So to implement a distributed timestamp server on a peer-to-peer basis, we will need to use a proof-of-work system similar to Adam Back's Hashcash, rather than newspaper or Usenet posts. The proof-of-work involves scanning for a value that when hashed, such as with SHA-256, the hash begins with a number of 0 bits. The average work required is exponential in the number of 0 bits required and can be verified by executing a single hash. For our timestamp network, we implement the proof of work by incrementing a nonce in the block until a value is found that gives the block's hash the required 0 bits. Once the CPU effort has been expended to make it satisfy the proof of work, the block cannot be changed without redoing the work. As later blocks are chained after it, the work to change the block would include redoing all of the blocks after it. So we'll kind of just, before we keep reading this here, let's just kind of cover what this is. It's a lot of kind of big words and maybe words that people aren't familiar with, but I mean, the general gist of this is the idea of proof of work is that you have to expend some kind of computational power to solve the proof of work algorithm. They don't really mention getting a block reward necessarily yet, but it mentions that essentially to find a block, it's the idea of solving the puzzle, essentially.
Yeah,
right?
It's like scanning for a hash value when there's only one out there, and you kind of have to do brute force to figure it out. So that scanning process isn't really anything that you can, like you have to use a lot of brute force, which we talk about like when using CPU power, to verify that, that single hash output, like is valid. So it's pretty much like a chain, like a proof of scanning, someone solving and scanning the problem for a certain value to get to the next one.
Yep. And basically it's saying here, if once enough effort has been expended to satisfy the proof of work, basically that block is set in stone. And as later blocks are added on top of it, you would have to go back and redo the work involved. Right. And so basically all that it's saying here is that this is a problem that gets more and more difficult. But then also as time goes on, the more work there is, the more energy someone would have to expend to redo the work as well.
And I think it's important to know that the nonce is like very unique, and it's always kind of dependent too on the previous one. So like when we're saying about like as later blocks are chained after it, the work to change the block would include redoing all the blocks after it.
Yep.
So that means like that nonce value and the previous nonce values, you would have to redo all the different works to modify the whole chain.
And that's what helps Bitcoin become the immutable ledger that it is, right?
Yep.
So we'll keep going, and so it continues after a little image displaying what we're talking about. The proof of work also solves the problem of determining representation in majority decision making. If the majority were based on one IP address, one vote, it could be subverted by anyone able to allocate many IPs. Proof of work is essentially one CPU, one vote. The majority decision is represented by the longest chain, which has the greatest proof of work effort invested in it. If a majority of CPU power is controlled by honest nodes, the honest chain will grow the fastest and outpace any competing chains. To modify a passed block, an attacker would have to redo the proof of work of the block and all blocks after it, and then catch up with and surpass the work of the honest nodes. We will show later that the probability of a slower attacker catching up diminishes exponentially as subsequent blocks are added. To compensate for increasing hardware speed and varying interest in running nodes over time, the proof of work difficulty is determined by a moving average targeting an average number of blocks per hour. If they're generated too fast, the difficulty increases. Wow. I know. Really, it's almost amazing when you reread this to think that the past 10 years have been wasted on so much crap, right? There's really a lot.
This is the last two paragraphs are extremely loaded with information. Yep.
We'll take it sentence by sentence. I think it's and everyone in the Bitcoin Cash world, this is what we've been. This is what we talk about when we say this is what Nakamoto consensus is. It's described very explicitly here in the white paper. So the proof of work also solves the problem of determining representation in majority decision making. Very straightforward, right? It goes on to say if the majority were based on one IP address, one vote, it would be subverted by anyone able to allocate many IPs. So this is precisely the problem with the idea that 80% of the nodes running software matter, right? That was never the way it was designed. It was never supposed to be, well, I have a computer, I have a vote, right?
Yeah.
Now, this is where they say proof of work is essentially one CPU, one vote. So you have a lot of these people that go, well, one CPU is in my computer at home, therefore I get one vote, right?
Yeah.
That's not what it's talking about. It's talking about your CPU has to expend effort on and we'll talk about this as we go to the network stage, but you only get a vote if you're solving the proof of work. That's the only way you get a vote, right?
Right.
And so it says specifically, the majority decision is represented by the longest chain, which has the greatest proof of work effort invested in it. Those two are equivalent. You're only going to get the longest chain if you have more proof of work. Now, everyone points to the whole BCH BTC thing as well. BCH, because of our difficulty adjustment algorithm, at one point was outpacing BTC. We were having a lot of blocks produced. I think it is still true. We still have more blocks, I think, technically, right? And so everyone goes, well, that disproves Satoshi. It's like, no, okay. The extenuating circumstances of different difficulties and all that kind of stuff, the white paper specifically is saying, assuming one chain with difficulty defined,
right,
the longest chain will always be the one with the more proof of work effort invested in it, right? Very straightforward. Very, very straightforward.
Yeah. Assuming no replay protection or anything.
Exactly. None of that stuff is in here, right? And so, again, the gist of this, it really kind of hammers this point home, which is why it's so surprising any of this was up for debate for the past 8 years, right? But if the majority of CPU power is controlled by honest nodes, the honest chain will grow the fastest and outpace any competing chains, right? Now, we're going to get to the incentive section soon. But everyone again, they look at this paragraph and they go, well, there's no guarantee it's controlled by honest nodes. But the whole point of the system is that you're incentivized to be honest. If you're trying to make money, playing by the rules is what makes you the most money, right? So it's not just saying, let's hope everyone is honest. It's actually relying on the fact that people want to make a lot of money, and therefore they're going to be honest. They want to make more money, therefore you're going to be honest, right?
Right.
And we'll get to that in a minute. But so to modify a pass block, an attacker have to redo the proof of work of the block and all blocks after it. And basically the gist here is that it's saying, again, the one that grows the longest chain is the winning chain. It says specifically, this determines representation in majority decision making. So the decision making process is this process of who can grow the longest chain, which automatically means who has more hash rate. And then this obviously, these 3 sentences describe the difficulty adjustment. So basically this is ensuring that the proof of work difficulty increases as more hashing power is added to the system. And this kind of is what creates that, what you call a red queens game. And we'll put a link to what a red queen, the article kind of describes it actually in depth, but a red queens game is pretty much the idea that you can't stay still. You have to continue competing, and the minute you stop improving, you lose, right? You kind of have to run to stay in place is the gist of the idea, right?
And I think it's kind of important to note that this moving average of difficulty, I think that in itself is like one of the innovations that Bitcoin had, is that it was able to create like a stable network of miners and users, because we saw with the difficulty adjustment, like miners would hop on, go crazy, and then drop off in order for the difficulty to go down. Like if you mess with this difficulty level of like trying to, or like if there is no accountability for like how much CPU power is being given to the system, this kind of controls that inflation rate and creates more of a stable system for the miners to always be there, always mining, and the people using it to always be there as well, selling it or whatever, using it.
I think there's a case to be made that once I think there's a very big case to be made that once PCH is the only chain that exists, because it's the only one with utility, there's probably going to be an argument to move back to the 2016 block difficulty adjustment. 2016, so changing the difficulty every 2016 blocks. Changing the difficulty dynamically may not make the most sense. But anyway, maybe it does. So that's fine. We can move forward here, right?
Yep.
So network, interesting stuff, right?
Yeah.
Interesting stuff.
Here, you want me to read this one?
Go for it.
All right. Number 5, network. The steps to run the network are as follows. 1, new transactions are broadcast to all nodes. 2, each nodes collect new transactions into a block. 3, each node works on finding a difficult proof of work for its block. 4, when a node finds a proof of work, it broadcasts the block to all nodes. 5, nodes accept the block only if all transactions in it are valid and not already spent. 6, nodes express their acceptance of the block by working on creating the next block in the chain, using the hash of the accepted block as the previous hash. Whoa.
Should we even just stop and take this apart?
Yeah.
Let's just make sure that this is very clear to everyone, right? This is defining what a node on the network is.
Well, yeah, it's defining all the steps to run the network, to run a node in the network successfully. Yep. And you don't get to pick and choose which ones you want. This is how it is.
And it says specifically, steps 2 and 3 specifically say, you put new transactions into a block and you find a difficult proof of work for the block. Very explicitly defined is that a node in the network is a miner. This has never been up for debate.
Yes.
It's been defined from the very beginning. Right?
Yeah.
So let's just get that out of the way.
Yeah.
Right? If anyone is still wondering, miners are the nodes as described in the white paper. Now, it doesn't mean other people can't interact with the network. But if you want to run the network, be a node in the network, you are a miner. Full stop.
Right.
Nothing else to say about that. Now, what I find actually pretty interesting, and this is what kind of gives credence to the idea that maybe Satoshi understood this small world theory. It says specifically that new transactions are broadcast to all nodes. I just find that interesting. Why is it written specifically that you have to broadcast everything to all the nodes, right?
Right.
It says specifically the block itself is broadcast to all nodes. Now, it makes sense why, like that makes intuitive sense, like why you would want to broadcast to all nodes. But as we find out, right, this concept of wanting to be densely connected for this broadcast to work is important to the small word theory. And to take even one step further, this kind of goes back to the idea of we talked about it when we interviewed Craig. He talked about this a bit. But this idea that like proof of work isn't just finding the hash puzzle. It's proving that you did the work. And this is really what these steps describe, right? Yeah. It's saying that, not only are you finding the proof of work, you're broadcasting it. And that's just as important as being it's just as important as finding the proof of work as it is as broadcasting that as rapidly as possible, right?
Right. I mean, all 6 of these bullets are pretty much like, they all have the same importance. Like, it's kind of crazy. Like, because you just said number one, new transactions broadcast all nodes. That's the importance of having a well-connected small world network in Bitcoin. We just went over 2 and 3. How like, it's not Raspberry Pi, so we're trying to keep the Bitcoin blockchain going. And then number 4, I mean, when a node finds a proof of work, it broadcasts it to all the nodes. You have to announce that you won. You have to be cocky or no one's going to give you credit for it. And like all of these are essential. It's crazy to me.
This one's kind of interesting to me too, right? Number 5 is almost even more interesting. It specifically talks about the double spend problem as well. And this is what interests me more when you kind of think back to this idea of, do you remember the hoopla around the Miners' Choice Initiative? And they said, we're not going to accept blocks that have double spends. This is exactly what's written about in number 5 of the network. Mm-hmm. It's specifically saying, are the transactions valid and are they not already spent? So everyone goes, well, that doesn't make, you can't do that. You can't do this. It's like, that was from the beginning how this was really supposed to work. That you're not going to accept the block unless everything in it is valid. Now the word valid.
Keep going.
I was just going to say the word valid is very interesting. This has been a topic I've seen in the Bitcoin Cash world. Everyone debating, well, who determines what's valid? That's not defined in the white paper. It's actually very clearly defined, as we'll find out very shortly here.
Yeah.
But the idea of what is valid is actually very clearly defined. And I just find it interesting. Number 5 here is exactly that idea of rejecting blocks that contain double spends. Exactly that idea. And yet, CoinGeek was torn apart over the whole thing. Why? Right?
Yeah.
And by the way, the white paper doesn't describe what valid is. Yes, it does, because it describes it in the very next sentence. It says your acceptance of the block implies that you accepted it because it's valid, right? And you create on top the block, and that's that. This is all defined, okay? So if you want to create the longest valid chain, try it. You're either going to win or you're going to lose. And you only win if you have the majority of people behind you. Mm-hmm. I mean, isn't it remarkable, Corey, how we can have this conversation and we're talking about 6 sentences. We're talking about 6 lines here.
Yeah.
You know what I mean? This paper it's a remarkable thing when you really kind of break down what it's trying to say, in my opinion.
And I think number 5 and 6 really contribute towards the efficiency of the payment system here. Like it really is describing an automated audit process pretty much for all these payments, all these transactions that are going through.
Yep.
It's pretty crazy, pretty remarkable.
It's just crazy that we're reading this in 2018. If anyone sees this in the future, this is 2018. Mm-hmm. And this is novel what we're talking about here. Yeah. That's the most remarkable part to me that people would still want to argue with us on this. So.
Right. And whatever. It kind of gets a little bit into, like the incentivization of like being an honest miner here a little bit. Because if you're not an honest miner and your block contains a double spend, then you're kind of screwed, So you want to be clean in order for that other rest of the nodes to follow you and accept your block, So it's kind of like you have to make sure that your test is good enough to pass, And you have to make sure that, you know, other people kind of follow you too and accept that as that you passed and you didn't cheat.
In build on what you're saying, there is no defined rule set. The rule set is only, can you get the majority of nodes to agree with you, right?
Mm-hmm.
And by the way, nodes are minors. This is all there is. It's just, you know what I mean?
Yep.
Oof. All right. Sorry. Carry on.
All right.
So let's finish the section out. Yeah.
Nodes always consider the longest chain to be correct one, and we'll keep working. Jeez, man, it's like we already thought. Like, all right, nodes always consider the longest chain to be the correct one, and we'll keep working on extending it. If two nodes broadcast different versions of the next block simultaneously, some nodes may receive one or the other first. In that case, they work on the first one they received, but save the other branch in case it becomes longer. The tie will be broken when the next proof of work is found and one branch becomes longer. The nodes that were working on the other branch will then switch to the longer one.
One more section.
And new transaction broadcasts do not necessarily need to reach all nodes. As long as they reach many nodes, they will get into a block before long. Block broadcasts are also tolerant of dropped messages. If a node does not receive a block, it will request it when it receives the next block and realizes it missed one.
All right. This one first, right?
Yeah.
So the first sentence is obviously everything we're talking about.
Yeah.
Right. The idea that
I had to laugh there.
Well, and again, because what's more frustrating is that this is still debated today, and this is being debated today with November on the horizon. Mm-hmm. Sorry, but the white paper is very clear. The longest chain is the correct one. That's all there is to it. And we'll keep working on extending it. Okay?
Mm-hmm.
So if two nodes broadcast different versions of the next block simultaneously, some nodes may receive one or the other first. In that case, they work on the first one they received, but save the other branch in case it becomes longer. The tie will be broken when the proof of work is found and one branch becomes longer. Right?
Yeah.
So this is very straightforward. This is very, very straightforward because not only it covers two things. Number one, it covers the idea that obviously it's very important to broadcast faster than your competitors, right? Again, incentivizing that small world connection.
Yeah.
But then number two,
if there's contradicting
yep,
blocks, you save it just in case, and if it becomes a longer chain, you end up following the longer chain.
That's all there is to it. That's all there is to it, right?
Yeah.
Now, the new transaction. So then this next. I mean, let's just again marvel at the fact that again this is still up for debate. That's remarkable to me. Now, the next section here. This is interesting, right? This is probably the first time you come here and you're like, well, maybe Satoshi couldn't have imagined how densely connected the network would have gotten, right? Because really none of this does not happen. This does not really happen in today's Bitcoin.
Mm-hmm.
You know, there are nodes that maybe are Raspberry Pis that receive things maybe late or something if two blocks are found very quickly. But for the most part, and don't get me wrong, this does happen if you have blocks being found simultaneously and things like that. But for the most part, I mean, things reach. If you're a miner, you're going to find out about the block pretty quickly, right?
Yeah.
But this is interesting. I did want to call this out because it says new transaction broadcasts don't necessarily need to reach all nodes. As long as they reach many nodes, they'll get into a block before long. What's also important by that is that as long as they reach many nodes, you can also do, this concept of Bayesian analysis. If you're a merchant, you really don't need to have a connection to every single node, right?
Right.
You just need a connection to most nodes because for the most part, the transaction will be received by most nodes. So, So we'll move on to the next section. Corey, fill in some time while I turn off my AC real quick. Sorry.
All right. Number 6, incentive. By convention, the first transaction in a block is a special transaction that starts a new coin owned by the creator of the block. This adds an incentive for nodes to support the network and provides a way to initially distribute coins into circulation, since there is no central authority to issue them. The steady addition of a constant amount of new coins is analogous to gold miners expending resources to add gold to circulation. In our case, it is CPU time and electricity that is expended. The incentive can also be funded with transaction fees. If the output value of a transaction is less than its input value, the difference is a transaction fee that is added to the incentive value of the block containing the transaction. Once a predetermined number of coins have entered circulation, the incentive can transition entirely to a transaction fees and be completely inflation-free.
Wow.
Should I just wrap it up?
Yeah.
And we'll just go back through it.
Yeah.
The incentive may help encourage nodes to stay honest. Whoa. Where have we heard that one, Connor? If a greedy attacker is able to assemble more CPU power than all the honest nodes, he would have to choose between using it to defraud people by stealing back his payments or using it to generate new coins. He ought to find it more profitable to play by the rules, such rules that favor him with more new coins than everyone else combined, than to undermine the system and the validity of his own wealth.
Wow. That can't be right.
Nah.
Satoshi was wrong. Core was right.
Unbelievable.
So, right. Okay. So let's break this down.
Yeah.
Right? So the first sentence or piece here is talking about the block reward.
Yeah.
Right?
First transaction of every single new block
Gives the miner a block reward.
Yeah.
Right. So this is that added incentive, right? And so the general idea here is, and this is the incentive to be honest in the case where maybe there aren't transactions, right? You want to be honest because you want the block reward. If you think Bitcoins are going to go up in value, which I would imagine you do if you are spending a ton of money to mine them, right?
You want the majority of nodes accepting that you got the new block reward.
Yep.
So that's kind of where that incentive comes in.
And this is also the issuance, right? So instead of having the Fed print more money,
right,
this is the issuance structure, and it's probably the most fair way you could issue coins into circulation, right? Because you're not just letting any arbitrary person that joins make coins for doing nothing. Again,
right,
you have to expend work to mint the coins, and it becomes a competitive game. So this is also the issuance, and it says specifically it's analogous to gold miners, right? So obviously, there's going to be a point where it's profitable to mine the gold that you're finding, and maybe there'll be a point where it's not profitable. But for the most part, it requires expending of work and effort, and that's why, the idea of why is gold valuable is probably a bigger question, but so is why is Bitcoin valuable. So this first paragraph really is, okay, so why should we trust Bitcoin as an issuance system?
Right.
And that's pretty clearly laid out, right?
And it kind of goes back to the moving average of like difficulty adjustment too. That was kind of explained. That's why it's kind of important for that difficulty adjustment to let this kind of stable inflow of new coins happen. So that, no one's easily mining this stuff, and it's crazy, and it's like inflationary fiat cash money. We don't want that.
Right. Oh yeah. No. And so now the question becomes, well, what about when the block reward is gone? Again, covered very, 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 very clearly.
Right.
Transaction fees. And it says specifically that the incentives remain the same because once you don't need inflation, you don't need more block rewards in the end, because basically once that number of coins has been generated, the incentive can transition entirely to transaction fees. And this is where you really kind of get back to that argument of like, this is why we need scale, right?
Yeah.
I find it remarkable. Again, I got into a heated argument here in town. So I asked someone, I said, do you think that, are you worried that with the miners halving coming up in 2 years, are you not worried that if their transaction volume doesn't increase drastically, that BTC will suffer? And for whatever, I mean, like someone who probably has never read this paragraph would say, they said, no, we'll be fine. We'll be fine. Right? But really, you have to understand that if there isn't large transaction volume, you have two options. You have one, low transaction volume with very, very high fees, which isn't sustainable, or you have very high transaction volume with low fees. And I've always liked, I think it's Craig that kind of gives this in his presentations. He says the analog to Coke, right? Coca-Cola, they sell a shit ton of Coke, but they don't make that much money on every can of Coke. They just ship a ton of it, and they make maybe a few cents on every can, and that keeps them a profitable business. So
yeah,
this is why it's important to scale to billions of transactions a day for sure.
This kind of touches too a little bit on like the problem with the store of value phase, because from what I've heard on my end is that people say that, because the work going into mining a Bitcoin, because that's so much expended energy that's being used on that, that'll make the value go up just by naturally. Like that's how it works. And this kind of goes into the problem of store of value and, having to have utility. Because if you just have that store of value, if Bitcoin struggles with like price of selling it back to fiat as a store of value, and that price tanks like it has in the past, I don't even know, it seems like forever, 9 months since December. If it keeps doing that, miners are eventually just going to hop off.
Oh yeah. And
when they hop off, the difficulty to keep the chain going, it goes way down. So it's and if you're only getting like 2 Bitcoins out of it, expending that less of energy, maybe it's just not even worth it anymore at that point,
Right.
So that's where this whole thing is like, Satoshi Nakamoto was describing a very like efficient transition system of how the system would evolve and how it would transition entirely to transaction fees. And that's like kind of where we have to let the free market, kind of run its course and do what it's going to do long term, not short term, not like 2018 to 2020 trying to sell my Bitcoin for Lambos, not that. It's like transition long term into a stable finance, efficient payment system.
Yep. So. And what's even more interesting is all of this is, again, wrapped up very neatly in this last paragraph of this section. The entire idea of miners being evil and, again, I mean, it's almost even hard to keep your composure talking about this because it's just it's insane. It's insane that this was always up for debate, but it's spelled out very clearly here that even if a greedy attacker, so everyone, we talked about this with Chris. Mm-hmm. Chris said specifically, if assuming this is true, if Craig and Calvin can determine the future of Bitcoin, right, then count me out, is essentially what he was. I don't know if he said count me out, but he was kind of just saying like, that's not a system I want to be involved in. He tweeted something similar to that, which fine. That's a fine statement, whatever else. But this spells that out very clearly that there is still no incentive to attack the system. There's still clearly, here's what I'm going to say about it. If Calvin, Craig, whoever else is spending a ton of money right now to get a lot of hash rate to do something, I don't think they're just stupid people that have a short-term play in mind and think they're going to somehow flip Bitcoin. I think they have a much bigger idea in mind as to how they're going to get a return on their investment. And I would imagine that the greed of being someone who's invested a lot in the system is going to find that the rules do favor them. And that generating coins with the block reward and validating transactions is going to do a lot more for their personal wealth than doing anything differently. Right. So, and that goes the same for Jihan. It goes the same for anyone. Is that, again, everyone goes this idea of a 51% attack. Sure, could a 51% attack happen? of course, that's a theoretical possibility, but it's still ignoring the idea of the incentives, right? And I think the selfish mining stuff gets this wrong too. And I know we never really cover that in a full episode, but I think because that also came up in the miners meeting, believe it or not, that came up in the miners meeting. And it's just, I don't think anyone takes this last paragraph. They either think he's wrong, which is fine. You can disagree that this is a true statement. Or you say, well, or you say that the attackers are just irrational, bad actors.
Right. It's and I understand some of the problems sometimes is they like feel like a centralized authority. They're so concerned about that. Because, we have talked about, like a central authority, problems with fiat, inflation. But like this paragraph describes exactly why someone wouldn't do that. Like you don't think like if Craig and Calvin had more than 51%, you don't think they would listen to their customers, essentially? You have to think about it. This is like a business perspective. You have to make sure that customers are coming through your door. And especially with Bitcoin Cash being as small as it is, and I can understand maybe someone's problem with, oh, it's so small, like it doesn't need to be controlled by a central authority at such a small, delicate state. Well, since it's at a small, delicate state, they have to make sure that their customers are coming through the door. And if they did something to attack the network that would lose a majority of their market, the price of it's going to go down currently. It's going to be insane. And I mean, that's the thing. People talk about Bitcoin having so much volatility. That's because it's so small right now. And if someone were to attack it lightly, it could crumble the price and everything of it back to fiat for now in the current circumstances that we're under. So I mean, like, I understand people's problem with centrality, but they need to keep in mind that with Bitcoin being at such a delicate state, they have to make sure that they're on top of their game too. So they're not ignoring everyone, they're also listening, making sure that they'll have customers, and make sure that this thing's good for the long term.
Yep. Incentives, right?
Incentives, yep.
So this, I guess this wraps it up, right? This wraps up sections 4 through 6. I think what would make the most sense for our next ones is it's a 12-part paper, so
yeah,
I think covering sections 7 through 9 makes the most sense.
Mm-hmm.
And then 10 through 12 to get to the conclusion. But this is part 2 of the series.
All right.
I think it's worth reiterating that if you're going to stick this out with us, which I hope you do, it's worth noting just how misunderstood 4, 5, and 6 are. And I think it's important that if you're listening to this, I think it's important to help people understand this stuff, because I think that, like, what I find the most compelling when I talk to people that are like, cryptocurrency blockchain enthusiasts, they haven't read this, and they'll lie to you, and they'll tell you, I have read this. And I'm sure there's a lot of people listening to this that have told people, yeah, I've read it, right? And you probably skimmed it and you didn't really read it. There's a lot of people that are going to be like, oh yeah, I read the Bitcoin Whitepaper. Bitcoin's old. It's, blockchain 1.0, right? But have you heard of Cardano? Have you heard of this? Have you heard of this? Have you heard of this, right? And yet they couldn't fully give you an explanation as to what 4, 5, and 6 really are saying.
Right. And I'll admit, the first time I read it, I found it a little bit confusing. There was a lot here. So I read it, I kind of took out what I wanted to, and like came to my own kind of conclusions. And I think that's what happens. What you're saying here is they kind of skimmed it. They've read it before, but they haven't really read it and see how each part affects the other part of it. Yep. Like the interoperability of each section in the white paper. Because that's what I started to realize, like the next couple times I started reading, it was like, whoa, well, that's because number 6 is so dependent on number 5 as well. and all these bullets here, 1 through 6, like
Yep.
they all go hand in hand together.
Yeah, I think it's
a shame.
it is a shame, but it's exciting. I think it's also exciting because when you read this, you really understand that, again, Bitcoin Cash is Bitcoin, right? And there's going to be a lot of people that are going to lose a lot of money when BTC goes to zero. But I think it's kind of exciting to let people know the real Bitcoin right now is worth $434, right? I mean, I'm excited. This is Bitcoin. Bitcoin's here. It's here to stay. So yeah, we can
awesome show.
Can wrap up the show here.
And just quick plug, if you haven't bought your CoinGeek conference tickets yet, go check it out on their website.
Yep. So. I'll pull it up the website again, actually, so for people just to see the thing. I'm excited about did you see, this kind of goes in hand with CoinGeek. They announced, Squire, their mining company,
oh yes,
Samsung is producing their chips. Kind of insane. So
yep, professionalization, baby.
Yep. Maybe we can have look at all these people that you can recognize in this here. I hope we have a unifying November again, but if not, may the longest chain win.
Yep.
So CoinGeek Week, we'll put a link. Make sure you want to sponsor it. If anyone listening has enough money to sponsor this thing, reach out. And then like and subscribe to our video as well.
Yep.
The after party, we'll have a lot more details on that soon too, but it sounds like that's shaping up to be a fun time as well. More of an experience than a party, I think. Yeah. And then, again, we'll kind of just tell you the agenda here. Application Developers Day, Application Merchants Day, and then the future. So all three of these, really excited about. It's gonna be a fun time. So I'm looking forward to it. And we got someone reaching out saying they wanted to hang out with us. So that's at least one person that wants to hang out with us. So if you're gonna be in town, let us know.
Yeah.
And we'll try and meet up with everyone. So
all right.
Cool. Great. We're at an hour exactly, so let's wrap it up.
All right, Beach Boys rolling out.
Perfect. See ya.
See ya.